Hello and welcome to the Geomestic channel. Today we're going to dig into the process of how to calculate areas of different pieces of circles. Take advantage of the printable guided notes worksheet that follows along with this video by clicking on the link below in the description. Now before we jump into finding the areas of these different pieces of circles, we first need to recall how to find the area of just a whole circle. Now to do this, we're going to break this circle into a bunch of sectors. A bunch of congruent sectors. Doesn't really matter how many. But what I'm going to do is I'm going to take each sector and I'm going to put them kind of right next to each other in this little pattern. Okay, I've got 8 sectors in this circle, so I'm just going to use 8 congruent sectors. I've got 4 across the top and then 4 across the bottom here. Okay, so together this whole circle and these 8 sectors represent the same amount of area. Okay, now this starts to look more and more like a rectangle the more and more sectors that I use. So I used 8 sectors. If I split this again, each one in half into 16, it would kind of look more and more like a rectangle. And I can do this as many times as I want into many different sectors. And of course, it's not going to be an exact rectangle because of the curvature of that circle, but I can get pretty close to make this kind of make sense. So if I want to find the area of something like this, a rectangle, the formula is just base times height. Okay, the formula for the area of a rectangle is base times height. So if I use this idea in a situation like this, what I'm going to do is I'm going to write the dimensions of this in terms of what we know about circles. So if base times height is the area, I need to know what the length of the base is and the length of the height. Okay, so again, I'm just estimating here, but this is going to get me pretty close to what I'm looking for. So the base of this, quote, rectangle that I have here is just half of the distance all the way around. So again, I've got 8 sectors. I've got 4 across the bottom, 4 across the top. The distance all the way around is the circumference. So 4 of the sectors would represent half of the circumference. Okay, so the base that I have here is really just half of the circumference. Okay, the other half of the circumference is up here across the top. The height of this, quote, rectangle is just the length of 1 radii. Okay, so we've got the radius here representing the height, and again, half circumference is the base. Okay, so if I use those dimensions and I input them into my formula here, the base being half the circumference, so base is going to be half circumference times the height, which I'm going to call the radius, and then circumference, because circumference is 2 times the radius times pi, or you might have seen it as pi times the diameter. 2 radii is just 1 diameter, so it's the same thing. So 2r times pi. If I write that here, half of the circumference, or 2 radius times pi, times the other radius, I can see that things start to kind of work out here. So area, half times 2 is just 1. Radius times radius is radius squared. And I've just got my pi right here. Okay, so you can see that using this idea of taking a circle and kind of transforming it into a rectangle, I can get to the formula for the area of a circle by using this rectangle method. Okay, so pi times the radius squared, or r squared pi, is how we find the area of any circle. Okay, so just a real quick example here. Let's say the radius was 4 inches. So if I were asked to find the area of a circle with a radius of 4 inches, I would just take the radius, square it. So 4 squared times pi. 4 squared is just 16. And that's all we got. Okay, so the radius is all we need to know. Square it, tack on the pi. Inches squared, units squared, whatever you have there. That's all it takes to find the area of a circle. Okay, so again, this lesson is about finding areas of different pieces of circles. The first piece we kind of already talked about is to find the area of just one sector of a circle. Now, a sector of a circle, just to define it real quick, a sector of a circle is a region bounded by an arc and the 2 radii that go to the endpoints of that arc. So if you got a circle here, you've got an arc, we'll say arc AB, there's A, there's B. I draw a radius to each endpoint of the arc. this portion right here is what we call a sector of a circle. So if I want to find the area of just a sector of a circle, okay, the area of that is just a fractional piece of the area of the whole circle. So once we know the area of the whole circle, which we just learned how to do, we just have to know what fraction of the circle this particular sector is. Okay, so we can know this by knowing what the measure of the arc is. Okay, so if the measure of the arc here, and when we talk about measure of an arc, we're talking about degree measure. Okay, so the degree measure, or the measure of the entire circle, is 360 degrees. So I need to know what the measure of just one arc would be. So whatever this angle happens to be, that's how I'm going to know what fraction of the circle I'm dealing with. Okay, so to find the area of just a sector, what we're going to do is we're going to find the measure of arc AB, so whatever that angle measure is, and don't forget that the measure of the central angle is the same as the measure of the arc. So if I know that central angle measure, that is the measure of the arc. I'm going to take that measure over 360. Okay, so that tells me what fraction of the circle I'm dealing with. And then I'm going to multiply that by the area of the whole circle. Okay, so area of a circle, which again we just recognize as pi times radius squared. Okay, so this right here is our formula to find the area of a sector. And we'll do the examples at the end here. Okay, so we're going to keep that in our back pocket here. The last piece of a circle that we're going to find the area of is what we call the area of a segment of a circle. Okay, now a segment of a circle is the region bounded by the arc and the segment that joins the two endpoints. So if I join the two endpoints A and B, what we've done is we've cut off this little piece right here. Get a different color. This little piece right here. And this is what we call a segment of a circle. Okay, so a segment is really just a portion of a sector. I like to think of it as like the crust of a pizza slice. So the sector is the whole pizza slice, and the segment is just the crust, just the end portion right up there. Okay, so to find the area of this guy right up here, what we're going to do is we're going to use this subtraction method. Okay, so if I can find the area of the sector, which we just wrote as this formula right here, I can subtract out the portion of the sector that isn't the segment. Now, what shape is that? Is this right here. Okay, and you can see that that is just a triangle. And the good news is that we have a few different ways to find the area of the triangle. Now, the big picture, though, is that to find the area of a segment, we just have to take the area of the sector minus the area of the triangle, and that gets us the area of the segment equals, running out of space here, area of the segment. All right, so those are the two kind of area formulas that we're going to do today. So the area of the sector, the area of the segment, which is the sector minus the triangle. All right, so let's get into some examples. So we've got our circle here. Right angle in the center, arc AB is right here, so we know the measure of that arc is 90 degrees. And we've got the sector, which is here, and the segment connecting endpoints A and B, the segment is right there. Okay, so the way we're going to do this is we're going to kind of look at three different areas. We're going to start with area of the circle, then we're going to go to area of the shaded sector, so it's in blue, and then finally we'll go to the area the segment, which is in purple. Okay, so we need each of these to kind of get to the next. So the area of the circle is first. Once I know the area of the circle, I can get to the sector. Once I know the sector, I can get to the segment. All right, so the area of the circle, the formula is just pi times the radius squared. I need a radius. I didn't get you one. So I got 12 centimeters, we'll say, is the radius of that circle. So if I want the area of the circle, take the radius, square it. So I've got 12 squared pi. Because multiplication is commutative, it doesn't really matter which way you go here. So I just flipped it around. 12 squared is 144. So the area of the circle is 144 pi centimeters squared. As always, depending on what the question is asking you, or how they're asking you to write your answer, if it's rounding or if it's to leave it in terms of pi, I'm just going to leave this one in terms of pi. 144 pi, I could go ahead and multiply 144 by 3.14. I'm not going to do that right now. So that's the area of the circle, 144 pi centimeters squared. Now to get the area of the sector, again, this portion, I need to know what fraction of the circle that sector happens to be. Now in this case, because I have a 90-degree angle, you can tell pretty quickly that this is just a quarter of the circle. But if I use that formula, the area of the sector as being the measure of the arc over 360 times the area of the whole circle. I know that the measure of the arc being the measure of the arc being 90 degrees, putting that over 360, which does reduce down to 1/4. That's how we get to know that that is 1/4 of the circle, times pi r squared, which again, that is the area of the whole circle. Luckily, we already found that, 144 pi. 90 over 360 is 1/4, and 1/4 of 144 is 36. So the area of the sector, which again is a fraction of the area of the whole circle, in this case the fraction is 1/4, that is 36 pi square centimeters. Okay, and last but not least, if I want to find the area of the segment of the circle, that was the area of the sector minus the area of the triangle. So again, I've got this whole sector right here. If I want just the purple portion, I'm going to subtract out the area of that triangle. And what's left over is, again, like just the crust of that pizza slice. All right, so we know the area of the sector, 36 pi. I'm going to subtract out the area of that triangle. Lucky enough, we have a right triangle. To find the area of a triangle, we just take base times height, where base and height have to be at a right angle or perpendicular to one another. Because it's a radius for the base and the height, it's just 12. The radius is the same regardless of where you draw it. So I've got the area of the circle, the area of the triangle. We know the formula for that is half base times height, which is just half of 12 times 12. 12 times 12 is 144. Half of 144 is 72. So the area of the triangle, 72 square centimeters. Now to write our answer, because I have the sector of the circle in terms of pi, there's the sector right here. I've got the area of the triangle, which obviously does not have a pi. I can write my answer like this. I can take the sector, 36 pi, minus the area of the triangle, 72 centimeters squared. I can't put those together, again, because this is in terms of pi, this is not, so it's perfectly acceptable to leave my answer like this if I want an exact answer. If I wanted to get this as a decimal, I can go ahead and multiply 36 times pi, which if you do that, you get 113.1, and then subtract out the 72, which if you do that, you end up with 41.1 centimeters squared. Okay, so either answer here is fine. We can go 36 pi minus 72, or we can go 41.1. Same goes for these in terms of pi. We can leave them just like this, and that's fine. All right. Let's do another one. Wow. Totally missed the ending of that one. There we go. Good enough. So this time we're going to go with a 45-degree central angle. There's the endpoints. We'll go with a 5-inch radius and my segment right here. Okay, so I'll just go ahead and shade in that little segment right there. And then the sector of the whole thing like that. Okay, so same thing. We're going to go area of the circle, area of the sector, area of the segment. Okay, area of the circle, again, pi times radius squared. Since the radius is 5, radius squared would be 25, 5 times 5. And then pi, 25 pi, or in inches squared. So the whole circle, 25 pi inches squared. The area of the sector is a portion or a fraction of that circle. What fraction would it be? In this case, my central angle is 45. So I take 45 over 360 times the area of the whole circle, 25 pi, we just found that. 45 over 360 does reduce down to 1/8. So that sector is 1/8 of the area of the whole circle. And 1/8 times 25, 1/8 of 25, that is 3 1/8. 3 1/8 pi inches squared. Okay, so we've got the sector area. To get the segment area, I'm going to take that sector area and I'm going to subtract out the area of the triangle that we have right there. Now, in the last example, the triangle that we had was a right triangle. Okay, we had a right angle, a 90-degree angle. This time we don't have a right triangle. We have a 45-degree angle as the central angle. So we can do a couple different things here to find the area of this triangle. I think the best course of action, and this really works regardless of what your central angle is we can utilize this this formula to find the area of a triangle using trigonometry. If you don't remember how to do that, I have a video about that. You can find that right up there. But the formula that you need here is the area of a triangle is 1/2, they call it BC, 1/2 BC times the sine of angle A. Okay, so this is the formula that we use. B and C are any two sides of the triangle. Luckily, again, two sides of the triangle we have is a radius, and the radius is the same. And then A is the angle that is in between those two sides, and we have that also as 45 degrees. Okay, so this formula, 1/2 BC sine A, we could have done that for the last example with a 90-degree angle, but since it was already 90, we could just do 1/2 base times height. This will work regardless of the angle. So 1/2 B and C, two sides of the triangle, they're both 5, times the sine of angle A, which is 45 degrees. Okay, so I'm gonna get my calculator out here. So I got 1/2 or 0.5 times 5 times 5 times sine of 45. And it looks like we got about 8.84. 8.84. So the area of the triangle, 8.84 inches squared. All right. So now that we have the area of the triangle, to get the area of the segment, we're going to take the area of the sector minus the area of the triangle. Again, we can leave it like this, 3 1/8 pi inches squared minus 8.84 inches squared. For this one, I'm going to go ahead and get just a decimal answer. I'm going to round it to the nearest hundredth here. So if you take 3 1/8 pi, 3 1/8 pi is 9.82 minus the area of the triangle, 8.84. Subtract those and you get 0.98 inches squared. So almost 1 square inch, 0.98 inches squared. All right, I think you get the idea. So these pieces of circles, to find the areas of these, we're just going to use strategies that we've used in the past, triangle areas, circle areas, throw in the sector area. We can get through these. It takes a little bit of time. You have to go through and be careful with your with your calculations, but if you take your time, not too hard. Appreciate you watching. If this was helpful for you, give it a thumbs up. And if you'd like to see more videos like this, be sure to subscribe to the Geomestic channel. Thanks a lot. We'll see you next time.